I've got tangent up on the board here, and as you can see, it fails the horizontal line test. Now I've just drawn 2 periods of tangent, but of course it does this again and again and again on either side of what I've drawn. Okay. So we want to create a related function that agrees with tangent, takes on all of its values, but hits those values exactly once. And we do that again by restricting the domain. And in doing that, I'm going to look at the graph, but I'm also going to think quadrants, because I'm going to be restricting the domain to an interval that corresponds to 2 quadrants worth of angles. 1 quadrant where it's positive and 1 where it's negative. And as usual, I always choose quadrant 1, the version that corresponds to acute angles. That would be between 0 and pi over 2. So we're going to keep that portion of the graph. So that gives me this right here. Whoops, that's pi over 2. Notice pi over 2 is not included here because it wasn't in the domain of the original function, so it can't be included in the domain when I restrict the domain either, but I'm going to include everything from 0 getting arbitrarily close to pi over 2. Okay. Then I know I never choose quadrant 3. I always want to choose an adjacent quadrant so that I can get a connected interval. And I want to choose a quadrant where tangent takes on its negative values. Now, if I just look at that, that's not enough to help me decide, because tangent is negative in both quadrants 2 and 4. But if I take a look at this graph, I can see that 1 is clearly a better choice. The version of quadrant 4 that's adjacent to the part of the graph that I kept would be from negative pi over 2 to 0. If I kept that, I would just get this 1 period of tangent. The version of quadrant 2 that's adjacent would be from pi over 2 to pi. Now, if I kept that, I would get the right half of this one and the left half of this one, but I'd have an asymptote smack dab in the middle. Okay, so I wouldn't get a connected graph. So sometimes just knowing the plus or minus sign of things is enough to know which of these 2 quadrants we want to keep. In the case of tangent, it's not. You want to, if possible, choose the adjacent quadrant that's going to give you a connected piece of graph. So I want to keep pi over 4. So from negative pi over 2 to 0, again, not including pi over 2. Okay. So this is the function I've created, y equals tangent of x, where x is in the open interval this time from pi over 2 to pi. Can't include those because there's no way if I'm restricting the domain I can suddenly throw in points that weren't in the domain to begin with. Okay, so this is an invertible function that agrees with tangent when it is defined, and it's the function that we're going to invert when we create arctan. So we can say y equals arctan of x. And again, if you prefer to write that as tan inverse of x, you can. That's an inverse sign, not an exponent. Okay, and this simply is what we get if we switch the roles of x and y. So it becomes x equals tangent of y, and the restrictions on x become restrictions on y. Y is in the open interval from negative pi over 2 to positive pi over 2. Okay. And I could write that out as a sentence. This means that y is the angle in this interval whose tangent is x. Excellent. So let's practice evaluating that. So let's evaluate arctan of 1. Okay, so what I like to do is give that a name, and again, a name that makes me think angle. So I call it theta. By doing that, I create this equation so that now I can rewrite the equation with the function I'm more familiar with, which is the regular trig function. Okay, so this is telling me that tangent of theta is 1, and theta's in this interval from negative pi over 2 to positive pi over 2. Excellent. Okay. So, two-step process. That's a positive number. This interval corresponds to quadrants 1 or 4, but tangent would be positive in quadrant 1. So I know that I'm looking for an angle in quadrant 1, so I'm looking for an acute angle. Okay. So it is its own reference angle. I don't need to worry about reference angles at this point. I'm just looking for, there's my theta, some acute angle in quadrant 1. And I know that its tangent has to equal 1. So that inspires me to draw my 45, 45, 90 triangle. 45 degrees is the angle whose tangent is 1. Okay. And that's going to mean that my angle is pi over 4. Remember, inverse trig is in radians unless otherwise specified. Okay. So this is pi over 4. Fabulous. Let's try another one. Let's try arctan of negative root 3. So again, I give that a name. I call that theta. That makes me think angle. And so then I can rewrite this. Tangent of theta is negative root 3, and theta's in that interval from negative pi over 2 to positive pi over 2. That corresponds to quadrants 1 and 4. That's negative. Tangent is negative in quadrant 4, so I know my picture looks like this. With arctan and arcsine, do be careful. We don't get to quadrant 4 by rotating more than 3/4. We get to quadrant 4 by rotating in the negative direction. Okay. So theta is going to be just the opposite of an acute angle. Okay. Alpha is going to be my reference angle. It's going to be essentially just the opposite of theta. Okay. What I know about that reference angle is that tangent of alpha gives me the absolute value of this, which is root 3. Because I always use the reference angle to figure out what's the absolute value that I would attach to that negative sign. Okay. Now, I actually don't have tangents of pi over 6 and pi over 3 memorized. But I know that this is going to be one of those because I see the root 3. So if you're familiar with the 30, 60, 90 triangle, or with the corresponding points that you would get on the unit circle, when you see root 3s, you want to think maybe it's 30 or 60 or pi over 6 or pi over 3. And when you see root 2s, that shows up in your 45, 45, 90. So I'm going to draw my 30, 60, 90, 1, 2, root 3. In order to get tangent of root 3, notice that would be root 3 over 1. So that's 60 degrees or pi over 3. So alpha is pi over 3. That was my reference angle. Theta is the opposite of pi over 3 because I've got to get into quadrant 4 by rotating in the negative direction. Fabulous. Okay, so I'm going to give you a couple of problems to try. I'd like you to evaluate arctan of 0, and then I'd like you to graph y equals arctan of x, and I'd like you to state the domain and range. And with this one, I'm going to add something to this. Describe the end behavior using arrow notation. Now, it's been a little while since we've done that. Hopefully you remember how that works. If not, don't worry, we're going to go over this in the next video. But try these problems before you watch the next video.